So hello dear students, in the today's lecture we will start the last chapter of mechanics book. It is elastic scattering, and the first topic is elastic scattering in lab system. So first of all, a question arises, what do we mean by lab system? So lab system is a coordinate system fixed with respect to laboratory or the observer. All the observations has been made by the observer himself in this coordinate system. So we draw a coordinate system here: x dash axis, origin, y dash axis, and this coordinate system is attached to the observer. Then we are working in a system called lab system, and here we have two masses, m1 and m2, m1 mass, m2 mass. m1 mass is moving with velocity u1 along the positive x-axis, and m2 mass is at rest. Then after some time collision will take place and both the particles will be moving along different directions. Let us assume that the particle m1 is moving in this direction and particle m2 is moving in this direction. Say this is m1 particle, this is m2 particle, and their velocities after collision are v1 and v2 respectively, and alpha and beta are the angles at which the m1 and m2 particles they move with respect to the positive x-axis. So now we have to solve this problem. So first of all we apply law of conservation of linear momentum along x-axis. So initial momentum is m1 u1, it is along x-axis. m2 second mass is at rest. Now we are to find the components of the velocities, and for the components we have to draw the perpendiculars like this. And these components will be, it will be m1 v1 cos alpha, m2 v2 cos beta. So it is m1 v1 cos alpha, m2 v2 cos beta. m1 u1 it is equal to m1 v1 cos alpha, m2 v2 cos beta. We mark this as equation number 1. Now we apply law of conservation of linear momentum along y-axis. So initial momentum is 0 because both the momenta, this is along x-axis, this is not having any momenta at all. So net initial momentum along y-axis is 0. Now when we come to the final momentum, so we will be having components. So it will be m1 v1 sin alpha, it will be m2 v2 sin beta. So we will be having m1 v1 sin alpha along positive y-axis. This negative sign because m2 v2 sin beta is along negative y-axis. So when we rationalize this, we will get equation number 2, m2 v2 sin beta, equation number 2. So now we apply law of conservation of energy to the total system. Kinetic energy, because it is a elastic collision, so kinetic energy will be conserved. So initial kinetic energy is half m1 u1 square, half m2, initial velocity is 0, half m1 v1 square, half m2 v2 square. And when we solve this, we will get half will cancel out. So now we have these three equations and we will solve these equations to get the desired results. Let us take m1 is equal to m2 equal to m, say. So this will simplify our problem. So from equation number 1, m will cancel out, so it will be u1 v1 cos alpha v2 cos beta. So we can write it like this. Let this is equation number 4. So from equation number 2, so it will be v1 sin alpha equal to v2 sin beta. We mark this as equation number 5. And from equation number 3, so this is our equation number 3. When we put m1 is equal to m2, m will cancel out, so it will be u1 square v1 square plus v2 square. So we can say it is like this. So this is equation number 6. So now we have simplified the equations 1, 2 and 3 to 4, 5 and 6, and now we are to solve these three equations. So square and add equation number 4 and 5. So it is u1 minus v1 cos alpha v1 sin alpha v2 cos beta v2 sin beta. So when we solve this, we will get u1 square v1 square cos square alpha 2u1 v1 cos alpha v1 square sin square alpha v2 square cos square beta v2 square sin square beta. So out of these two terms, v1 square will be common. Inside it will be sine square plus cos square, so it will be v2 square. And from equation number 6, we substitute the value of v2 square here, and we will get u1 square, v1 square, 2u1 v1 cos alpha, u1 square minus v1 square. So this will cancel out. So it will be v1 square plus v1 square, 2u1 v1 cos alpha. So 2v1 square, 2u1 v1 cos alpha. So 1 v1 cancels out, 2 cancels out. So v1 will reduce to u1 cos alpha, and we will mark this as equation number 7. So now from 6 and 7, so now we look at the equation number 6. It is u1 square minus v1 square. So it is u1 square minus u1 cos alpha. We substituted the value of v1. It is v2 square u1 square cos square alpha, v2 square. So v2 square is equal to u1 square 1 minus cos square alpha. Cos square alpha is sin square alpha. So v2 it is equal to u1 sin alpha. So this is equation number 8. So now from equation number 5, 7 and 8. Equation number 5, 7 and 8, v1 sin alpha. So value of v1 from equation number 7, u1 cos alpha sin alpha. v2 equation number 5, this v2 sin beta. Sin alpha cancels, u1 cancels, so cos alpha it will be equal to sin beta. So sin 90 minus alpha, it is equal to sin beta. So 90 minus alpha, it is equal to beta. So which implies alpha plus beta, it is equal to 90 degree. So this is the conclusion, that in a lab system, when a incoming particle collides with a second particle at rest subject to condition m1 is equal to m2, then this angle is 90 degree. So now we write the conclusion. So if a particle undergoes an elastic collision with another identical means of same mass particle, and second particle is at rest in lab system, one particle colliding with another identical particle, second particle at rest in lab system, then after elastic collision, the two particles will move perpendicular to each other. The directions of the particles after collisions will be perpendicular to each other. So dear friends, this completes our today's lecture. Keep in touch. Thanks a lot.